Moving into the online cost tool, the first step is to get affiliate membership through the IMechE. It can be found on the IMechE website. Once that's established, you get your login details and you can get onto the site. From here, as you can see on the screen, you get a login screen which will have your username and password, which will be in an email with your IMechE number. So login's the first step. From here, you can see previous submissions, the submissions that you've got for the rest of the year, your details which must be up to date before the event itself. If you do have any additional questions past what you found in the rules, these videos and publications and previous documents, you can ask a question on the IMechE site. So that's just through here. And then if it's against one of the rules, you can then detail that and one of the judges will get back to you as soon as possible. You can see questions that you have submitted, key searches for any other questions you may have, and then apply for affiliate membership if you haven't done so already. So to find the cost section of this, we go into document submission, scroll all the way down. You can see there's a hyperlink for the cost report. Click that is where you'll find the online cost tool used for this year's event. So in here, you'll be able to create a new cost tool or edit an old one. You can also snapshot to create separate iterations or revisions for whichever tool you're using. You can export it to a PDF document, which will then be used as your submission, and then rename it. A hint here is to make sure that you rename them or keep them named well. By doing this, you can make sure that your revisions are kept tidy and you don't lose them along the way or start working on the wrong ones. The final one in here is you can upload an image of the vehicle, which has to be done for the submission itself. So in here, if you go into Edit, you can see the impact attenuator CBOM that was used to create the PDF document associated to this video. In here you can add extra steps or even remove them if you need to. So the first step would always be to create a new part. From that part you can then choose which assembly it's in or which system it's in. So for this example we're looking at the frame and body, and then in the assembly being the impact attenuator. We decided to make the impact attenuator instead of buying one in. And then if you have any relevant comments, you can put them in the comments section, and then obviously quantity below. So for this one, we obviously only had one impact attenuator for the vehicle. So coming out of here, we have separate assemblies for them. And then you scroll down, you can see each individual part that makes up that assembly. Each team can decide whichever way they want to create the DBOM and CBOM. If you wanted to have all of the parts together, or if you wanted to break the parts down within the associated processes for them. For this example, we had single parts. From there we added the material, and then the process, any tooling that might be needed, and then any machining after that. And then finally coming into the top level assembly, where we would then assemble using hand tools depending on what was needed for it. This is where we had all the fasteners and tooling required. Past this, to add processes, materials, tooling and fasteners, you go into that tab. You can click whichever system you want to go into. From here there are recommended materials, processes, fasteners and tooling to pick from. However, if you can't find the one you are using, there is a new variant down the bottom. There you just add whatever material you are. So if you are using unobtainium, you can put it in there. Ooh. Again, same with the comments on this one. Add any relevant cost comments or detailed comments. This could be the price per hourly rate or which cost section you are looking into. That's very much going to be dependent on which cost method you're using. So one of the final processes for the CBOM is exporting to PDF, which you'll have to do to put into the zip file for your submission. So by clicking export to PDF and opening the link, you can see we have a cat paying homage to our Austrian friends over the Austrian competition. Big shout out to them. But lower than that, you can see the detailed bill of materials or costed bill of materials depending what you've exported. So here is what the judges will see. So keeping this clear and precise and make sure the information is readable and professional is key to this. As you can see, without that, this could be a mess of numbers and words and very difficult to follow. This obviously becomes more and more important as you go through to the explanation file. So looking over an example of a new costed bill of materials or detailed bill of materials, we'll take a snapshot of the IA example that we've used for the PDF document. So we'll confirm that. And then as you can see underneath, we have a new version. We'll rename this for cost video and then we'll update from there. So editing this one, we can now go through and delete any lines we might not want or whatever the next revision for this section is. So there is a delete function for each line, just go careful what you are deleting, which we'll go through now. This is somewhat of an arduous process. There we go. So now we have a clean slate to build a new costed bill of materials or detailed bill of materials. So always starting off with a new part. To start off with, we will make a manufactured part. So we'll call that, let's go with the chassis to start off with. So that would go in frame and body, and in the assembly itself, depending on what chassis we're going to make, if it's going to be a composite material or a monocoque, we might choose to go for the body materials, body processes. However, I think we're going to go for a steel space frame, which would be frame and frame tubes. So we're going to manufacture this. Under here, we're going to make any relevant comments that we want to make. So for the time being, we're just going to put frame, and we only want one because we're only manufacturing one. So just a quick point here, if you were going to show scalability in the CBOM or DBOM, you could then change the quantity here. If you wanted to impress the judges and show that you had manufacturing knowledge not only on a single unit, but maybe 50, 100, and maybe even 100,000, and show how the manufacturing processes might change, you could do that in the online cost tool. But however, we'll keep it simple to start with and just use one. So now we have a part. We have the chassis, we have a frame. Underneath here, we need to put all the materials associated to it, all the processes, and possibly any toolings we're going to need along the way. So if we keep this as our top level assembly, which we'll just chuck that in here, frame assembly, and save that one, we're then going to need more parts. So to start off with, we're going to need chassis tubes. You could do this as however many single parts you needed per tube, or roll them all into one, depending on the processes you're going to need. That's very much up to the team and how they want to go through this. So the chassis tubes, we're not going to make them. We're not going to cold roll our own steel. We're going to buy them in. For example, for these ones, make sure that everything that is bought in, no matter if it's sponsored, given for free, legacy parts, anything like that, is costed. The total value of the vehicle is not being judged. It's all looking at the methodology and the cost theory that you've used along the way. So again, we're still in frame and body at the moment. We're going to go down and we're going to stay within the sub-assembly of frame and tubes, but this time we're going to buy the tubes. As you can see underneath, the tab has changed. We've now got comments, quantity, cost price in euros. The whole event is done in euros. Please make sure that the exchange rate is written down in the explanation file and is known by the team when they are presenting it, because it may change. And then we've got cost comments. This could be, again, anything you think the judges should know about as you're reading this, or anything that might help you remember along the way. So if we go into comments, we'll put chassis material, go through quantity. So say we're going to make the chassis out of one material, ROPT 510 or something similar. Oh, spell that right. These ones are going to cost £50 as a random price, and we're going to have that as price per metre, or whatever unit of measure. So now we have a top level assembly and material. So from here we need to turn that material into the chassis. So the steps associated to that will come under the processes. So if we carry on through the chassis, we can go into the process. Under here there is a list of generic processes that could be used throughout the manufacturing of an FS car. However, again, if there's one that you're using that isn't there, the new tool is underneath for any sub-assembly you may need. So to start off with, we are going to cut the tubes down to size, or if we're going to do that by hand, or we're going to use tube notching as a single axis, or we're going to use laser notching. It's very much dependent on the facilities that the teams are using or the facilities you have regularly available. So for us, we are going to go cutting manual, and we're going to cut them down before we put them into the tube notcher. So from here, any comments we could put in here with tube notching. Depending on how many chassis tubes we have and how many we have to notch, could be in here, so an arbitrary number, we'll say 50. So this is, again, depending on how you've worked this out in your cost explanation file. Are you subconning this? Are you doing it in-house? If you're doing it in-house, what's the labour rate for that process? What's the operational expenditure for that piece of machinery? This all needs to be worked out in your cost explanation file because it's what builds the costed bill of materials. So we'll have an arbitrary number to start off with and we'll base it per hour. We'll say it's 15 euros and we'll put that price or even cost per hourly rate. And then if you wanted to, you could have the time within it and we'll say that it's going to take us an hour if it's automated, probably going to be a little bit longer than that. So we now have material and we're starting a process. So here is where the cost will start building up. Moving into the next process, we're going to prep the tubes ready to go into the fixtures before we start welding. So again, this is another process which will go into the PMFT. So we'll drop down into process, come down, move that one up as such. And we're looking for tube prep, which is somewhere down here. There we go, tube process. So in here, we'll put in welding prep. So this could be all sorts of things. It could be deburring on the sides of them, or making sure that you have a chamfer around the outside to be able to weld with, or even just cleaning up whatever comes off from the notching that you've done on the previous step. So again, we have around 50 tubes, but we've decided in this one we're going to cost it per time. So again, there's different ways to look at the costing. You don't have to do it exactly this way or the way shown in the PDF document. It will be different for every team and different depending on the cost method you use. So this time we're going to have quantity as an hour and we're going to use it purely as an hourly rate. So we're going to have, say for tube, it's going to be a fitting job, so we're going to say it's 12 euros an hour. Again, costed per hourly rate of 1 hour to go through all of the tubes. So from there, we'll drop that one in, which means now we have not just materials, but we have the cut tubes and they're prepped ready for welding. This could be where tooling's needed or fixtures to be able to fixture onto the welding table before we start. So if we go into that one again, drop down into tooling, come down, welding fixtures. So this again is very much going to be dependent on how you're manufacturing your car. If you're doing a composites monocoque, it's going to be a very different process, a very different tool than if you're using a steel space frame. You still have to go into the same level of detail, it's just going to look slightly different. So from here, we're going to put welding table jigs to weld frame. Again, for this one, we're only going to need one. So also this tooling could change depending on the scalability of what you're manufacturing. If you're only making one vehicle, then it might be possible to use MDF to do this. You're only going to use it once. You could then cut the MDF out and get the chassis out. If you're making 100,000 of them, that's very much going to change. You don't want to be throwing away your jigs every time you manufacture one. You may look at using steel. You may even look at having a prefabricated jig from there. So because we're only manufacturing one, we've decided we're going to use MDF to make our jigs. We're going to laser cut them out. We know that there's going to be a bit of discrepancy when welding and there could be some deformation, but we're going to take the risk on that one. So cost for those is time spent on the laser cutter plus the material. So we'll add these in later on as a new part, so we know that we've got the costs associated to them. So we've decided to get the laser cutting done. It's going to cost us, say, £100 worth of material plus running on the laser cutter. So we're going to have price per material plus spelling laser cutter. These could be broken down into 2 steps in the CBOM. You could do the material and then the laser cutter. However, for the sake of this, we'll throw them in together. Save that. So now we've got material that's ready to go into the jigs, and we have the jigs. So the next step would be setting up all of the material and all of the parts into the jigs before welding. So moving into the welding bay, there are obviously other processes that could be associated to welding of the chassis. The tubes may need heat treatment. There may be other aspects before you start welding, but for this video we'll keep it as simple as possible to give an overview. So the next process is weld. We're going to have 2 or 3 processes under the category of weld, which could be tube prep, putting them into the jigs and fixtures, tacking, straightening, seam welds, or more iterations of the above. So we'll chuck it in as weld to start off with and assume that we've done all of them. So weld prep plus jigs plus tack plus weld. Obviously in the actual event these will have to be separate operations, but just to show the detail you can put in, we'll carry on like this. Again, we're only manufacturing 1, so that's fine with that one. And then cost to manufacture these, so we have to take into account the amount of time taken. So for welding a steel space frame chassis takes an awful lot of time, so that's going to be your hourly rate plus the equipment plus any consumables you've used, such as welding wire. Other is going to be running the machine itself, and anything else you would have had in your explanation file. Again, make sure to have cost comments to further justify the figures you're using, and then we save that. So although this is a very, very simple example, these could go into much more detail. You could make sure that each chassis tube has its own part, because obviously some of them will be notched, some of them won't, some of them will need more weld prep, some of them won't. You have different gauges depending on what you're doing. You know, make sure to check the rules under the chassis part of this, so you know what is structural and what isn't, and the different material grades that you'll use within the steel space frame. So really you can go into as much detail in this as you like. In summary, we've looked at a very basic model for the DBOM and CBOM, the idea being that yours would be much more in depth and having a lot more time spent on that. The biggest thing to remember is the detail used within this. You have a year to create the cost documents. Make sure there's enough detail that the judges understand what it is you're trying to show, and they want to see every nut, bolt, washer and turn of a screwdriver in the detailed bill of materials. There is, however, a balancing act between concise information and detail over too much. The judges want to see that you have thought of every aspect, but it doesn't need to be you sweeping the floor at the end of the day and making sure that the kettle's on in the morning. So that's it for this one, and we will see you in the next video.